Hey guys, today we're stepping into one of the strangest mysteries the universe has ever whispered to us. The quiet disappearance of stars. Not exploding, not fading slowly, not transforming into something we can predict, but simply vanishing, as if someone gently reached into the sky and switched off a light. You're here, watching the night sky in your mind, feeling its quiet immensity stretch around you. A familiar star twinkles in the dark, and then, without warning, it's gone. No sound, no flare, no final burst of brilliance. Just absence. A space where something once lived. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And as you settle in, let me know in the comments where you're listening from tonight and what the sky looks like where you are. Even if it's behind clouds, city lights, or just your imagination. Wherever you are, let the world slow down for a while. Soften your gaze, let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. You begin by observing that familiar darkness overhead. A slow, tranquil canvas of pinpoints hanging in the cold. In this stillness, you notice how fragile each star feels. They seem eternal, yet you already know they aren't. Some burn out with titanic endings, exploding as supernovae that scream across the galaxy. But a few rare ones behave differently. They choose silence instead of spectacle. You imagine yourself looking through an old star chart from centuries ago, with a cluster of stars carefully drawn in ink. One position on the parchment is marked brightly, but when you look up at the actual night sky, the spot is empty. No red light, no blue shimmer, nothing. If you didn't know better, you'd think it was a mistake, but ancient astronomers noticed it too. A star once existed there. Now it doesn't. As you breathe slowly, you let the ideas settle. Stars are disappearing in ways that defy our expectations of physics. And although the universe is full of billions of stars, losing even one without explanation feels like losing a story, a cosmic biography with the last chapter torn out. You picture astronomers today comparing old photographic plates, sliding them back and forth, blinking between centuries. On one plate, a star shines clearly. On the next, separated by decades or less, the star is simply gone. No afterglow, no shockwave, no expanding cloud of stellar debris. If the universe were a movie, this would be the moment someone taps rewind in disbelief. Researchers call them vanishing stars, but the term barely captures the eeriness. Something massive enough to shine across light years cannot just turn off like a light bulb. And yet, that's exactly what the data seems to show. You drift further into the thought. Perhaps the star collapsed inwards so quickly that even its death was swallowed whole. Perhaps thick cosmic dust now lies between us and its light. Or perhaps, and this is where astronomers still argue gently, the star never vanished at all, but slipped behind the curtain of a cosmic illusion we don't fully understand yet. But deeper still is a stranger possibility. What if stars can die differently than we thought? Not with the roar of a supernova, but with a soft, invisible sigh. You picture a giant star nearing the end of its life, its layers trembling with unstable fusion, its core collapsing into something unimaginably dense. But instead of exploding outward, the collapse continues inward, pulling everything with it until a black hole is born in total silence. If that happens, and many scientists now suspect it does, the star's final moment would leave no trace. Its light would reach us for a while longer, then suddenly stop, like a candle blown out in a vacuum. And as you hold that thought, the sky above you feels a little more mysterious. Not frightening, just deeper, older, filled with quiet processes happening out of sight. The kind of mysteries that remind you how small we are and how vast the universe truly is. Tonight, you're not just learning facts. You're watching a cosmic story unfold. A story of stars that choose to end their lives quietly, slipping out of the universe without a goodbye. And as the darkness settles gently around you, you prepare to follow this mystery deeper. You're still gazing into that soft, endless night when you begin to sense the weight of history behind this mystery. The stars above you tonight are not only points of light, they are echoes of every observer who ever looked up in wonder. And as you let your breathing slow, you drift back through centuries to a time when the sky was the only clock, the only map, the only source of cosmic truth. Ancient astronomers watched these same patterns, memorizing every glimmer with a devotion that feels almost sacred now. Imagine standing beside one of them, a scholar in Babylon, perhaps, or a monk in medieval Europe, or a Chinese court astronomer carefully keeping track of celestial events. The instruments are simple, perhaps just the naked eye, a wooden sighting tube, or a star map drawn on silk. Yet their patience is immense. Night after night, year after year, these early sky watchers memorized the heavens in a way we rarely attempt today. Now imagine their shock when something was wrong. A star that should have been there was missing. No comet blocked it, no storm, no seasonal haze. Just disappearance. A void where light was supposed to be. In several ancient records, scholars wrote about stars that forsook their positions, or heavenly lights that failed to appear. Some texts describe them with almost poetic bewilderment, as though the stars themselves had lost their way. These notes were often dismissed as errors, copying mistakes, clouded nights, misidentified stars. But you feel something different as you stand beside those early observers. There's a sincerity in their confusion, a sense that they truly witnessed a vanishing, even if they lack the language to explain it. Picture an astronomer of the Song dynasty in China, making precise sketches of star clusters. One night, he pauses, brush hovering over parchment. Something is wrong. A star he has tracked for years, carefully inked in dozens of charts, simply isn't visible anymore. He checks again, and again, and again. The night is clear, the air cool, the sky sharp and dark. Yet the light is gone. He records the disappearance, perhaps assuming it will return. It doesn't. Centuries later, an astronomer in Persia notes a similar absence. A star once counted among the constant lights has become unaccounted for. He marks it quietly in his manuscript, unsure what he has witnessed, perhaps believing it to be some trick of the heavens. You breathe gently as you imagine these moments, letting their uncertainty wrap around you like a soft cloak. These fragmentary notes, scattered across continents and ages, form a subtle thread, hints of a mystery woven through human history. For a long time, scholars assumed every vanished star must have exploded in a supernova lost to time, or perhaps faded too slowly to notice. It took modern astronomy, with its photographic plates and digital sky surveys, to reveal that something stranger might be happening. But before we reach the present, you find yourself drifting further into the past, to the incredible patience of observers who spent their lives tracking the night sky. In places without artificial light, the stars must have seemed more alive, flickering, shifting, dancing with tiny variations. To them, the sky was predictable, dependable, a celestial order that rarely faltered. Losing a star was like a trusted friend failing to arrive for a nightly meeting. You can almost sense their unease. What does it mean if a star can disappear? Is it a message? A warning? A celestial omen? In many cultures, vanishing stars were indeed treated as signs, not of astrophysics, but of destiny. Yet beneath the myth, beneath the symbolism, is a simple human reaction: confusion. The feeling you get when something familiar suddenly isn't there anymore. A quiet ache that the universe is misbehaving. Even as you stay grounded in the calmness of the moment, you can imagine how these lost stars haunted early observers. They didn't have the tools we have. No telescopes, no spectroscopy, no satellites, no way to know if the star had dimmed, moved behind dust, collapsed into darkness, or torn itself apart silently. All they had was the void. This quiet absence becomes even more fascinating when you consider that humans were not wrong about the stars. Their maps were astonishingly accurate. Their sky-watching traditions, from Polynesian navigators to Greek astronomers, recorded tiny details that match modern measurements. So when one group said, "This star is missing," it wasn't carelessness. It was evidence. You let this realization settle into you like a soft, warm weight. The mystery of disappearing stars is not new. It's not a modern puzzle born from digital data. It's a whisper from antiquity, heard by countless generations and still unresolved. You imagine an ancient astronomer rolling up a star chart, extinguishing an oil lamp, and leaving his observatory with a lingering question: why would a star vanish? What force in the universe could erase something so bright, so distant, so powerful? He had no way to know that. Thousands of years later, scientists with telescopes the size of buildings would ask the exact same question, with just as much wonder. And now, here you are, continuing that lineage of curiosity, watching, listening, breathing slowly as the sky stretches open around you, following a trail of vanished lights that span centuries. You stand in a long tradition of people trying to understand why something so constant could slip away without warning. And tonight, you step deeper into the mystery they never solved. You continue drifting through the quiet night sky, letting your thoughts move gently from the past to something far stranger. The idea that the universe might hide doorways, not the kind made of stone or wood, but of pure gravity. As you breathe slowly, you imagine the darkness thickening in one small patch of space, not because the starlight has faded, but because something invisible has begun to feed. And in that moment, you step into one of the most provocative theories surrounding disappearing stars: the possibility that primordial black holes are silently consuming them. The thought settles softly into your mind like a grain of stardust. These black holes, if they exist, are not the giants born from supernovae. They are relics of the early universe, ancient, miniature anomalies formed just fractions of a second after the Big Bang, when space itself was shaking with unimaginable density. Some theorists believe these tiny black holes may still drift through the cosmos today, invisible, wandering like cosmic ghosts. You picture one now, not a roaring monster, but a silent seed of gravity, no larger than an asteroid or even a mountain. It drifts without light, without warmth, without any sign of its presence. But it has mass, just enough to distort the space around it. And if such an object were to pass near a star, the dance between them could become fatal. You imagine a star, bright and ancient, burning peacefully in its corner of the galaxy. For millions of years it shines steadily, unaware of anything unusual. But then, somewhere far out at the edge of the system, a dark visitor arrives. It doesn't announce itself. It gives no warning. The star's light doesn't flicker. Its surface doesn't tremble. Everything appears normal, until the moment the primordial black hole reaches the star's outer layers. At first, you imagine There would be only the faintest gravitational tug, so subtle no telescope could detect it. Then the tug becomes stronger. The star's own gravity pulls inward, but now something inside it begins pulling even harder. A tiny core of darkness slips beneath its surface like a needle disappearing beneath fabric. And once inside, the star is doomed. The black hole would begin eating its way inward, not violently, but methodically. It doesn't tear the star apart. It consumes it from the inside out. Its gravity grows as it feeds, but the process remains astonishingly quiet. No explosion, no supernova, no spectacular spread of glowing debris, just a hollowing, slow, silent final. You breathe softly as you imagine the star's core collapsing inward, its light still shining outward for years, decades, maybe centuries. Even as the darkness eats deeper, the observers on distant worlds would never know. The star looks unchanged, but inside, everything is unraveling. And then, one night, far from the doomed star, a telescope on Earth might capture a moment like this. A star that once glowed suddenly does not. Its light stops, not gradually, but abruptly, as though a cosmic switch has been flipped. There is no fading plume, no afterglow, just absence. Some scientists argue that primordial black holes are too hypothetical to blame, while others point out that, if they do exist, their effects will be almost impossible to observe directly. And that's exactly what makes this theory so tantalizing. It explains the silence, the lack of debris, the sudden disappearance, all without violating the known laws of physics. You let yourself picture the universe through this lens, a place where invisible predators roam through star fields, devouring suns without leaving a trace. It's eerie, but there's a softness to the idea too. These relics would be ancient, older than galaxies, drifting through space with no intention other than to follow the gravity that guides them. As you relax deeper into the thought, you realize something else. If primordial black holes exist, they might be incredibly common. Perhaps millions drift through the Milky Way alone. Perhaps one has already passed near our own sun without us knowing. It wouldn't cause harm. It might not even leave a mark. But somewhere far away, another star might have already vanished because of one. Scientists continue debating this. Some say the math supports it. Some say it doesn't. Some argue these black holes could even explain parts of dark matter. Others insist they are too speculative to take seriously. Yet the mystery of disappearing stars sits stubbornly in the middle, refusing to go away. Something is causing these vanishings, and primordial black holes remain one of the most quietly compelling possibilities. As you breathe slowly, gently, letting the darkness of space settle around you, you picture that small doorway in the sky. Not a portal in the science fiction sense, but a gravitational opening into silence. A star drifts too close, crosses the threshold, and vanishes from the universe's visible stage. No sound, no warning, just a star that once was, and then wasn't. Your mind stays with the image as it fades like a dream, preparing you for the next step in this cosmic mystery. The possibility that sometimes a star doesn't need a visitor at all to disappear. Sometimes it collapses into silence entirely on its own. You drift even deeper into the quiet of the cosmos, and now your focus settles on something profoundly intimate. The final breath of a massive star. Not the dramatic, world-shattering explosion you've heard about in supernova stories, but a gentler, stranger ending. A death so silent it almost feels like a disappearing act. As you breathe slowly, imagine a red supergiant glowing softly in the depths of space. It's enormous, millions of kilometers wide, Yet tonight you're seeing it not as a fiery monster, but as a tired old lantern trembling at the end of its fuel. For millions of years it has burned, growing swollen and unstable as nuclear reactions in its core struggle to hold back gravity. You picture the moment when the reactions falter. Deep inside, where the temperature and pressure are unimaginable, the star's core begins to collapse under its own weight. Usually this collapse triggers a massive rebound, an explosion so fierce it outshines galaxies. But not always. Sometimes the core collapses and keeps collapsing. No rebound, no explosion, just a deepening fall inward. This is the phenomenon scientists now call a failed supernova. A star reaching the threshold of destruction, but instead of erupting outward, it folds in on itself, forming a black hole in near total silence. You imagine the layers of the star feeling the core vanish beneath them, as though their anchor suddenly gave way. For a moment, the outer layers continue shining, unaware of the catastrophe brewing at their center. Then the collapse accelerates. Gravity takes command, and everything, light, heat, and matter, begins spiraling down into the newly formed singularity. If you could watch from a safe distance, the star would still look normal. The surface would glow with the same dusty red shimmer it had yesterday. Nothing would hint at the chaos within. Even as the star collapses, its light continues traveling across the galaxy, reaching your eyes long after its true self has disappeared. Then comes the final moment, one of the quietest events in the universe. The surface layers lose equilibrium and cascade inward. They aren't blown outward in a supernova. They simply fall. The star dims and then goes dark, as though extinguished by an unseen hand. To a distant observer, to us, it vanishes. Not gradually, not with a farewell burst. Just a sudden absence, a star that was there, and then wasn't. Scientists have observed candidates for these silent collapses. One of the most famous was a red supergiant called N6946 BH1. It shone brightly for years, and astronomers monitored it expecting a supernova. But instead of exploding, it faded. Not over centuries, but over mere months. Infrared light lingered for a while, like embers under ash, but the visible star was gone. Deep telescope observations revealed no explosion, no debris cloud, no lingering glow. It simply disappeared. You let your thoughts settle around the strangeness of it. A star collapsing into a black hole should be one of the most violent events in the universe. And yet, here it is, quiet enough to miss entirely. Quiet enough that humans only discovered the phenomenon a few years ago. Some astronomers argue that failed supernovae could be incredibly common, perhaps even the primary way large stars die. Others push back, saying the evidence is intriguing but not definitive. They debate whether dust clouds, unusual light patterns, or temperature drops could explain the disappearance instead. The discussions are gentle and ongoing. No one fully certain, everyone fascinated. You imagine being there in the star's final second, floating in the emptiness as the star's outer shell dissolves inward. There's no shock wave, no burning debris, just a slow acceleration toward darkness. Light bends around the forming black hole, disappearing past an event horizon that expands quietly, like a ripple in deep water. And yet, from the outside, the universe remains tranquil. The night sky doesn't flicker. The star doesn't scream. It just stops. Your breathing stays slow and steady as this realization settles in. Some of the most massive, most powerful stars in the universe may end their lives with no ceremony at all. No drama, No fireworks, just a silent fold inward, leaving a black hole in place of a star. A cosmic tombstone with no epitaph. It feels almost poetic. A life that ends by becoming smaller, tighter, quieter, until even light cannot escape. A star that chooses to leave the stage without applause, without spectacle. And this quiet ending provides one of the simplest explanations for disappearing stars. They're still there in a way, but trapped beyond a boundary we cannot see. What we witness is the universe removing a light from its canvas, leaving only the faint memory of where it once stood. Tonight, as you rest deeper into this story, you hold the image of a star collapsing not with violence, but with grace, disappearing into the very gravity that once held it together. A soft ending for something once so bright. You ease further into the stillness of the cosmos, and now the darkness surrounding you begins to feel textured. Not empty, but layered, like a veil drawn softly across the stars. As your mind drifts, you start to sense that the universe is not a clear, transparent stage. It is filled with storms of dust, islands of gas, and drifting clouds so dense they can swallow starlight whole. And tonight, you're stepping gently into one of the simplest, yet most easily overlooked explanations for disappearing stars, the cosmic dust that hides them from our eyes. Take a slow breath as you imagine a star, bright, steady, shining for millions of years. From your vantage point in the galaxy, it seems eternal. But between you and that distant point of light lies the interstellar medium, a sprawling ocean of microscopic particles and cold molecular clouds. These grains are tiny, smaller than smoke particles here on Earth, yet arranged through space in vast, glowing structures that twist like silent storms. Now imagine that over thousands of years, one of these clouds drifts, expands, or collapses along your line of sight. Not fast enough to notice day by day, but steadily enough that one night, after countless others, something is different. The star is missing. Not gone, not dead, just hidden. A single cosmic curtain has slid in front of it. You picture the dust cloud, cold, dark, shaped by magnetic fields and turbulence, thick enough to block visible light, but thin enough that infrared could still slip through. This kind of cloud is common. Entire constellations have regions where stars vanish behind filaments of dust, only to reappear from a different vantage point centuries later. Astronomers call these patches extinction regions, where dust absorbs or scatters starlight so effectively that even a giant star can be erased from the visible spectrum. That quiet disappearance would look, to an unsuspecting observer, exactly like the star had died. Tonight, you imagine drifting closer to one of these clouds. It's not empty at all. It shimmers faintly with reflected starlight, metallic grains of iron and carbon glinting in the darkness. Long tendrils curl like smoke, shaped by ancient stellar winds. If you reach out gently with your thoughts, you can feel the immense scale. Some clouds stretch light years across, vast enough to hide entire clusters of stars behind them. And they move, slowly, gracefully, but inevitably. A star whose brightness seemed steady for millennia can vanish in the span of a decade if the dust density along your line of sight increases. And this can happen for many reasons. The collapse of a molecular cloud, turbulence in a nebula, shock waves from a nearby supernova, or even the gravitational pull of passing stars rearranging the dust. Astronomers debate this often. Some point to cases where a star's disappearance was accompanied by an infrared glow, a telltale sign that the star is still shining behind the dust. Others argue that dust alone cannot explain certain vanishings that seem too sudden or too complete. They point out that some stars disappear without any trace in infrared or radio wavelengths, suggesting something far stranger than dust may be at work. You breathe slowly as you visualize a massive emissive nebula, dense enough to devour starlight. The Hubble and JWST images of such regions show spectacular beauty. Ridges, towers, valleys, all sculpted in cosmic dust. The same dust that births stars in its depths can also hide them from view. Perhaps the universe is simply reclaiming the light temporarily, letting dust cradle the star like a cocoon. Still, there's a subtle mystery that lingers. Some stars vanish too completely, too suddenly. Dust can darken a star gradually, dimming it over time. But in a few observed disappearances, the drop is abrupt, from bright to gone, without warning. Could dust clouds rearrange themselves so fast? Possibly. Under certain conditions, yes. Turbulence and gravitational instabilities can cause dense patches to form quickly, like fog rolling in across a coastline. As you let this thought drift, you begin to feel the cosmic dust not as a threat, but as a quiet storyteller. Every particle is ancient, forged in the depths of stars, cooled across eons, and now shaping the night sky in ways we barely understand. Dust doesn't destroy stars. It just hides them. It softens them. It turns sharp light into whispering shadows. And perhaps that's part of the beauty of this mystery. A disappearing star might not be a death at all. It might be a moment of cosmic concealment, where the universe draws a curtain so slowly and softly that we only notice when the star is finally gone. Tonight, you're learning that not every disappearance is an ending. Some vanishings are illusions. Some are nature's way of dimming the lights. Some are simply the quiet movement of a universe full of drifting veils. And the star, whatever it is, wherever it went, may still be shining, hidden behind a curtain of ancient dust, waiting for the cosmos to open again. You drift deeper into the story of vanishing stars, and now the darkness around you begins to feel stranger, heavier, as if something in the cosmic night is absorbing light itself. Not dust, not distance, not collapse, something darker, something that does not shine, does not burn, does not radiate. Tonight, you're stepping gently into one of the most haunting possibilities. Objects so faint and cold that they steal a star's light simply by existing near it. Take a slow breath as you imagine a star glowing quietly in the void, unaware that it is not alone. Nearby, hidden in the darkness, waits a relic of stellar evolution, a black dwarf, the final, frozen state of a once bright white dwarf. It is one of the coldest, quietest objects the universe could ever create. In reality, black dwarfs may not exist yet. The universe is too young for white dwarfs to cool that completely. But the physics predicts them. Future corpses of stars, chilling over trillions of years until all thermal light fades. Now imagine this invisible remnant drifting into place between you and a distant star. Unlike dust, it doesn't just dim the light, it blocks it, a solid shadow in the void. But you wouldn't see its silhouette. You wouldn't detect its temperature. It gives off no glow, no radiation, no infrared warmth. It is simply dark. If such an object passed through a star field, the star behind it would seem to vanish just long enough for astronomers to notice. No explosion, no collapse, just a star that disappears when an unseen visitor crosses paths with it. But black dwarfs are only part of this story. There are many kinds of dark objects that could play the role of a celestial thief. Brown dwarfs, star-like bodies that never ignited fusion, glowing only faintly in infrared. Rogue planets, drifting worlds with no sun, wandering silently between the stars. free-floating black holes, invisible except through their gravity, capable of lensing or erasing light. Cold neutron stars, collapsed stellar cores, so small and dark they vanish into the night. All of these objects share one trait. They could pass in front of a star without announcing their presence. As your breathing slows, you imagine a small, dark object, perhaps a rogue planet, drifting through the galaxy. It moves silently, unbound by any star. It crosses a distant light source, blocking it for days, months, maybe years. Astronomers on Earth compare two images, one from decades ago and one from tonight. In the first image, the star shines clearly. In the second, the star is gone. A thief has passed in front of it, leaving the universe unchanged except for our view. This is not just theory. Microlensing surveys have already found rogue planets and faint dwarf stars that reveal themselves only by the brief distortions they cause in background starlight. The galaxy is full of dark wanderers, thousands, millions, maybe billions of them, all drifting silently across star fields. Now imagine something denser, colder, older. A neutron star with no thermal glow left. It is no larger than a city, but heavier than our sun. It bends light around it, distorting the background sky like a warped mirror. If one of these corpses wandered across a line of sight, the star behind it would flicker, distort, or disappear entirely. Not destroyed, just hidden by an object too dark for our telescopes to notice. Astronomers debate this possibility frequently. Some argue that dark objects cannot fully explain sudden, long-term vanishings. Others counter that we have barely begun to map the invisible population of cold stellar remnants that likely fills the galaxy. These objects do not announce their presence unless they interact with something, and most of the time, they don't. You drift deeper into the thought that the universe might be crowded with unseen shapes, a cosmic ocean filled with drifting shadows. They don't harm stars. They don't consume them. But sometimes, purely by coincidence, they slide perfectly into place, erasing a star from our view like an eclipse in the middle of nowhere. It's a gentle kind of mystery. There's no violence, no destruction, just geometry, just motion, just the quiet, elegant mechanics of gravity at work. And yet, there's something almost poetic about it. A star can shine for millions of years, radiating across unimaginable distances, and still be hidden by a passing speck of cosmic darkness. A star's brilliance, undone not by explosion or collapse, but by the simple act of being blocked. As you let this idea settle, the night sky around you feels fuller, not empty, but alive with invisible things. Shadows drifting through the starlight, wanderers with no names, ancient remnants from stars long dead, and maybe, just maybe, one of these silent travelers is the reason a star you once saw is no longer there. A thief of light, passing by without ever realizing it carried a mystery in its wake. You breathe softly, preparing now to explore something even more speculative, a possibility that reaches beyond physics as we know it, into the domain of minds far older and more advanced than our own. You're floating deeper into the quiet, star-filled dark when your thoughts drift toward a possibility that feels both unsettling and strangely fascinating. The idea that the universe may not belong solely to natural forces. That perhaps, somewhere among the billions of stars, there exist civilizations capable of reshaping their surroundings in ways that could make a star disappear from our view entirely. As your breathing softens, imagine a distant star, bright, stable, millions of years old, and picture an intelligence far older than us studying it the same way we study our sun. Not with curiosity alone, but with the power to harness, redirect, or even obscure its light. You let the thought settle. Perhaps some vanished stars are not victims of collapse, dust, or darkness, but the quiet handiwork of advanced civilizations. This idea isn't born from science fiction alone. It echoes a real scientific concept. Megastructures, vast, engineered constructs so large they could eclipse a star. You may have heard the most famous of them, a Dyson sphere or Dyson swarm, an immense array of energy-collecting satellites built around a star to harvest its power. If something like this were constructed, the star's light could slowly fade, becoming dimmer until only infrared emissions remained or vanish from view entirely. But now, imagine something even subtler. Not a complete enclosure, but a partial structure, a vast ring or network of collectors, passing between us and the star, blocking the star's light in patches or completely. To an astronomer on Earth, this would look like a star that blinks irregularly, fades gradually, or disappears without explanation. We've glimpsed hints of such mysteries. Take Tabby's star, a strange, flickering beacon whose bizarre dimming pattern sparked worldwide speculation. Most explanations lean toward dust or unusual stellar activity, but for a brief, electrifying time, the idea of alien megastructures was seriously considered by researchers, not as the most likely scenario, but as one that couldn't immediately be ruled out. You breathe gently as you imagine a civilization capable of such an undertaking. Their technology would be beyond anything we can conceive, yet their motives might be mundane. Energy, sustainability, survival. Perhaps they shield a star to protect themselves from powerful radiation. Or perhaps they harvest its energy in ways that dim the starlight we see. Now imagine that from our perspective, after observing the star for decades, the light slowly weakens. 1 year it is bright, a decade later, noticeably dimmer, and then gone. No explosion, no debris, no stellar collapse, just a star whose light has been intercepted by something vast. Astronomers debate this carefully, with cautious excitement. Some argue that megastructures would produce unmistakable heat signatures, infrared warmth radiating outward as waste heat. Others suggest that a sufficiently advanced civilization might hide that heat, distributing it across wavelengths we cannot detect. A few researchers propose that we might have already seen civilizations manipulating starlight, but lack the tools to distinguish natural variations from artificial ones. You let these possibilities drift through your thoughts gently, like thin clouds moving across the night sky. They're speculative, yes, but not impossible. The universe is old enough for civilizations to arise, evolve, and expand far beyond what we can imagine. If we survive long enough, we may try similar feats ourselves one day. Now picture something more dramatic. A colossal artificial object, perhaps a planet-sized shield or a swarm of autonomous collectors, drifting into alignment with Earth. A shadow passes over the star. It dims, and then the star vanishes entirely, replaced by a faint residual glow or nothing at all. Is the star still there? Yes. Has it died? No. It is simply hidden behind a structure built with purpose, intention, and extraordinary engineering skill. Yet, as you float deeper into this thought, you sense a gentle contradiction. If a civilization could build such a structure, would they want to hide it? Or would they even consider that someone across the galaxy might be looking? Some astronomers argue that megastructures are too speculative for serious consideration. Others insist that, until all natural explanations are exhausted, we cannot dismiss them. After all, the universe doesn't owe us simplicity. It may already contain wonders shaped by minds unfamiliar to us. As the idea softens, you return to the peaceful rhythm of your breathing, imagining the night sky filled not only with stars, but with possibilities, with structures, intentions, and mysteries so vast they blur the line between nature and intelligence. And maybe, just maybe, somewhere out there, the light that has vanished from our sky is shining still, but hidden behind a work of engineering beyond our wildest imagination. You let this idea drift away softly, preparing now to step into something equally strange, but entirely natural, a phenomenon of gravity so powerful that it can bend, distort, or even erase the path of starlight before it reaches your eyes. You drift deeper into the cosmic quiet, and now the darkness around you feels less like emptiness and more like liquid space, bending, flowing, warping in ways that almost seem alive. As your breathing softens, you begin to sense something profound. The universe is not the straight, orderly expanse it appears to be. It is curved, distorted, shaped by the invisible pull of gravity. And sometimes that gravity becomes so extreme that it changes the very path of starlight, making a star appear to flicker, shift, or disappear entirely. Tonight, you're stepping into the strange and mesmerizing world of gravitational lensing, the bending of light by the gravity of massive objects. Most lensing reveals distant galaxies in beautiful, magnified arcs. But when the gravity is intense enough, or when alignment occurs with eerie precision, something far stranger can happen. A star's light can be bent away from us so completely that it seems to vanish. Take a slow breath as you imagine a beam of starlight traveling across billions of kilometers, moving steadily toward your eyes. It passes through the quiet vacuum of space without resistance. But then, somewhere along that unimaginably long journey, the light encounters a massive object, a black hole, a cluster of dark matter, or even a dense neutron star drifting between you and the star. Gravity grips the light gently at first, bending it inward. The beam curves, follows the warped geometry of space-time, and emerges in a slightly altered direction. This is lensing, the universe's own optical illusion. Usually it makes stars appear brighter or duplicated. But under rare, perfect conditions, the lens becomes a thief. Imagine the massive object drifting just slightly more into place. The starlight that once headed toward you is now bent away, redirected into the void. Your star hasn't died. Its light has simply been pulled aside, guided along a different path. Weeks pass, maybe months, maybe years, and still, no photons reach your eyes. The star seems to have disappeared. You can picture astronomers comparing sky images in disbelief. In one frame, the star shines confidently. In the next, it is gone without a trace. No explosion, no dimming, no debris, just absence. Some scientists call this phenomenon gravitational microlensing blackout. It is rare, delicate, and fleeting, but possible. A compact object passing precisely in front of a star can redirect its light entirely for a short period of time. A black hole or neutron star could achieve this more dramatically, bending space-time with such force that the star's light is swallowed into a curved path that never intersects Earth again. You breathe slowly as you imagine floating out near the lensing object itself. You don't see the star behind it. Instead, your view is a swirling distortion, like looking through rippling water. The gravity is so strong that it stretches and twists the field of stars. And if the alignment is exact, The star you came to observe is positioned perfectly behind the distortion, its light bent away from every possible viewing angle. The star still exists. Its entire life continues undisturbed. But from your position, and from Earth, it has been erased. Now, picture something even stranger. Invisible mass. Dark matter, the ghostly substance that fills the universe, could also cause lensing strong enough to distort a star's light. Although dark matter doesn't glow or reflect, it shapes space-time with tremendous force. A clump of dark matter drifting between Earth and a distant star might bend the light so subtly over decades that astronomers see a gradual dimming, followed by disappearance. No explosion, no infrared remnant, no collapse, just a quiet rerouting of photons. Some astronomers argue that dark matter lensing could explain a handful of mysterious vanishings observed in long-term sky surveys. Others counter that the alignment required would be extremely rare. Yet when you consider the vastness of the galaxy, billions of stars, trillions of possible alignments, even rare events must sometimes occur. You let your thoughts rest on this idea. The universe itself may act like a trick of optics, shaping the way you see reality. Stars that appear bright may actually be magnified. Stars that seem faint may be bright, but partially lensed away. And stars that disappear may simply be hidden behind the gravitational mirage of unseen masses drifting silently across the dark. There is something soothing about this explanation. It suggests that the universe is not unstable or violent, just complex. That stars don't need to die to vanish. They only need to lie behind the wrong object at the wrong moment. As your breathing remains slow and steady, you feel the strangeness of this truth wash over you. Sometimes disappearance is an illusion, a graceful bending of light, a cosmic misdirection, reality shaped not by destruction, but by the silent curves of space-time. And now that you've stepped into this world of invisible distortions, you're ready to move forward into the realm of modern technology, where satellites and space telescopes watch the sky with precise, unblinking attention, searching for answers to mysteries like these. You drift comfortably through the quiet darkness, and now your awareness shifts toward the instruments we've placed above our world. Silent watchers orbiting far beyond Earth's atmosphere. These satellites and space telescopes gaze upward with eyes far sharper than our own, uninterrupted by clouds, light pollution, or the trembling of the air. As your breathing slows, you begin to sense how these machines have become our companions in the search for vanished stars. Tonight, you step into the realm of modern space observation, where disappearing stars are not myths or misunderstandings, but data points, real, documented, and deeply puzzling. Imagine a telescope floating hundreds of kilometers above Earth, the Hubble Space Telescope. Its lenses are cold but alert, constantly capturing tiny changes in the sky. Decades of observation have allowed astronomers to compare images taken years apart. A star seen clearly in 2005 might appear dimmer in 2010, and gone entirely by 2015. When the pictures are placed side by side, the difference is undeniable. Now imagine the next generation joining the search. The James Webb Space Telescope. Its gold-plated mirrors stretch open like a cosmic flower, drinking in wavelengths of light the human eye can't see. Infrared, mid-infrared, the faint glow of dust and collapsing stars. Webb sees all of it. And when a star disappears, Webb can check whether it still glows behind the veil of a dust cloud, or whether it has fallen fully into silence. You float beside Webb now, as if drifting with it through the cold void. Its sensors hum softly, detecting the faintest warmth from ancient galaxies. when it turns toward a suspected, vanishing star. Its instruments gather every scrap of infrared light. Sometimes they find a lingering ember, a clue that the star still burns behind dust. But other times, there is nothing. Nothing in infrared, nothing in any wavelength. The star is simply gone. But Webb is not alone. You drift imagination first through a constellation of satellites. Gaia, mapping the positions and motions of more than 1 billion stars with exquisite accuracy. If a star moves or dims even slightly, Gaia records it. And Gaia has already flagged candidates that behave strangely. Stars whose brightness changes sharply or whose expected position suddenly lacks a detectable source. TESS, scanning wide fields for tiny dips of starlight caused by planets, but also noticing when entire stars behave unexpectedly. Some stars monitored by TESS have undergone abrupt, unexplained fades. Not flickers, not slow dimming, sharp drops. WISE, the infrared surveyor that first uncovered vanished stars lacking any visible counterpart. WISE found objects that shone brightly in one decade and disappeared in another, leaving astronomers with a mystery that matched ancient accounts. Light that once existed simply isn't there. You breathe gently as you imagine each of these satellites as a pair of eyes, blinking in slow motion across the heavens. Their data streams back to Earth in thin threads of radio signals. Scientists examine the numbers, compare past to present, coordinate with ground telescopes. The pattern repeats. A star is there, then a star is not, and no explosion marks the transition. One of the most intriguing sets of candidates comes from the vanishing and appearing sources during a century of observations. VASCO Project. Astronomers combed through nearly 100 years of sky images, hunting for stars that existed long ago but no longer appear in modern surveys. Hundreds of possibilities emerged, each one a tiny question mark glowing in the darkness. Most have simple explanations: dust, errors, overlapping objects. But some remain stubbornly mysterious, stars that undeniably existed and yet cannot be found now, in any wavelength or at any depth. As your thoughts drift slowly, imagine scientists working late into the night, staring at their screens. Two images sit side by side. Left, a field of stars from the 1950s. Right, the same field today. A small point of light on the left has no counterpart on the right. It is not dimmed, not distorted, not misplaced, simply absent. They zoom in, recheck the coordinates, compare filters, cross-reference catalogs. Still gone. And in that moment, even seasoned astronomers feel a flicker of awe. Not fear, not alarm, just the quiet realization that something happened in the universe while we weren't looking. Something invisible, instantaneous, and deeply significant. You imagine Webb turning its gaze toward one such vanished star. The data scrolls in. No infrared trace. No warm dust. No hidden remnant. The algorithms confirm it. Whatever once burned, there is no longer shining in any form detectable to us. Astronomers debate whether this indicates a failed supernova, a black hole formation, a dust veil, or a passing dark object. But the data is real, uncomfortable, beautiful. The universe gently reminding us how little we truly see. And yet, there is comfort in this mystery. Our satellites, these quiet sentinels, are watching the cosmos for us with unwavering patience. They are catching vanishings we would never notice. They are expanding our sense of wonder, revealing a universe in motion, subtle, unpredictable, alive. As you drift beside them in your imagination, the Earth spins softly below, a blue sphere wrapped in cloud. Above it, the telescopes keep their vigil. Their sensors wait for the next flicker, the next silence, the next star that once was and now isn't. And tonight, so do you. You drift deeper into the stillness of space, wrapped in the calm rhythm of your breathing. And now you begin to sense the conversations unfolding far below, in quiet offices, glowing observatories, and late-night research labs where scientists argue, question, doubt, and wonder. Because even with all the data from satellites, telescopes, and surveys, nobody fully agrees on why some stars disappear. And this uncertainty, as gentle as it is vast, becomes the next chapter of your journey. Tonight, you're stepping into the world of scientific debate, where mystery is not a problem, but a landscape to explore. Imagine a conference room filled with astronomers from around the world. The lights dim slightly as the first speaker walks to the stage. A slide appears, 2 photographs of the same patch of sky. One shows a bright star, the other shows nothing. The murmurs begin. This is not an illusion, not a measurement error, not a smudge on the lens. A star that existed in one snapshot of time does not exist in another. The debates begin gently. One group argues for failed supernovae, the silent collapses you've already imagined. They point to red supergiants that dim and vanish without a trace, suggesting that most of the star is swallowed inward before any explosion can escape. But others counter that these cases are rare, and that most failed supernovae should still leave some infrared signature, a warm glow behind the dust, which isn't always found. A second group argues for dust obscuration, claiming that sudden changes in dust clouds could explain abrupt vanishings. It's just the universe drawing a curtain, they say, but critics gently shake their heads. Dust tends to dim stars gradually, not erase them overnight. And some missing stars show no infrared emission at all, no sign of a dust cloud heated by starlight. Then comes the third camp, the ones who believe in lensing events, where gravity bends starlight away from us. They argue that dark matter and invisible compact objects could distort light paths so completely that a star could vanish from our view for years at a time. But their opponents note that such perfect alignments are rare and would typically produce distortions or brightening before the disappearance, signs that, in many cases, are not present. You breathe softly as you imagine the discussion shifting toward primordial black holes, ancient, hypothetical relics from the early universe. They could slip through stars, devour them quietly from within, or redirect their light. The idea is thrilling and terrifying in equal measure. But like all bold theories, it receives resistance. Too speculative, some say, too little evidence. Yet no one can entirely dismiss the possibility. And then, of course, comes the most controversial suggestion of all. Megastructures built by advanced civilizations. The room grows quieter. Some scientists smile politely, others lean forward with interest, and a few shake their heads. It is not the preferred explanation. Science always seeks the natural before the extraordinary, but it remains part of the conversation. Astronomers recall Tabby's star, a real example of inexplicable dimming that ignited debate around megastructures before settling on dust as the most likely cause. But some still wonder, if a civilization could harness the energy of its star, wouldn't the star's light change in ways we might misinterpret? You drift further into the debate, feeling the subtle difference in tone. This is not argument as conflict. It is argument as discovery, minds testing their ideas, theories meeting counter-theories, questions spawning more questions, a dance of uncertainty. One astronomer proposes that disappearing stars may be stellar mergers caught at strange angles. two stars spiraling into one another, their combined light temporarily obscured. Another suggests massive pulsation events, where certain dying stars shed outer layers in sudden bursts, creating temporary eclipses. A third proposes magnetic catastrophe models, where a star's magnetic field could shift violently, altering the way light escapes its surface. None of these explanations fit all cases. That is where the mystery lives. You float above this debate as though hovering over a calm sea of voices. Everyone here shares the same quiet frustration. The universe is not giving up its secrets easily. Each missing star leaves behind only silence, and astronomers must interpret that silence like detectives reading the absence of footprints. Some researchers argue that the problem is deeper. Perhaps we simply do not have enough historical data. The sky has only been photographed systematically for a century. Before that, all we have are ancient descriptions, hesitations, fragments of stargazers' notes. Maybe stars have always vanished. Maybe this has always been part of the universe's quiet rhythm. Others disagree. They believe we are witnessing something new, a sign of previously unknown physical processes revealing themselves only now that we have the tools to see them. You breathe, slow and steady, as the room fades into the soft cosmic background. The debate's quiet. The questions settle like dust. And in this stillness, you realize something important. Disagreement does not weaken the mystery. It strengthens it. The disappearing stars remain unsolved because the universe is vast, subtle, and infinitely creative. The scientists, with all their instruments and experience, are like listeners hearing a faint melody from deep underwater, trying to understand its shape, its rhythm, its source. And now, gently carried by this uncertainty, you drift towards something more playful, more imaginative. The world of thought experiments, where scientists test wild possibilities simply to see which ones might illuminate the darkness. You drift deeper into the quiet hum of the universe, and now your mind begins to wander into a softer, more imaginative realm. The space where scientists allow themselves to ask what if, not because they expect the universe to obey their ideas, but because thought experiments reveal the edges of what might be possible. As your breathing slows, you sense that these mental explorations aren't just playful exercises. They are tools, gentle, curious ways to illuminate what ordinary reasoning cannot yet explain. Tonight, you're stepping into a landscape of cosmic thought experiments, where disappearing stars become puzzles to test the limits of physics, creativity, and our understanding of the cosmos. Imagine yourself in a quiet observatory, sitting beside a blackboard. The sky outside is still and clear, and across the board is written one simple question: how can a star vanish without a trace? A scientist stands beside you, chalk in hand, ready to test ideas the same way someone tries keys in a lock. Not expecting each one to work, only hoping one might fit. Let's start with something wild. The scientist whispers, what if a star simply moved? You picture a massive star shifting position, as though nudged by a gravitational giant. Could a star be accelerated so suddenly, so violently, that it flings itself out of its place in the sky? The scientist sketches a robed black hole passing close enough to sling the star like a stone from a slingshot. You imagine the moment of encounter. Gravity pulling, space bending, the star's entire path being rewritten. It would not explode. It would not collapse. It would simply, from our perspective, vanish. But then the scientist gently shakes their head. A kick that strong would leave traces, they say. Changes in nearby stars. Ripples. Motion. Nothing subtle. So the chalk moves again. Thought experiment 2. What if the star entered a pocket of space where physical laws behave differently? You imagine a region of space-time twisted by enormous gravitational waves, the aftermath of a black hole merger or the edge of a cosmic string. In such regions, light itself might be redirected, trapped, or delayed. A star could still shine, but the path of its light could be distorted so profoundly that none of it reaches you. You let the idea settle. A cosmic blind spot, a flaw in the fabric of space that hides a star without harming it. But again, the scientist pauses. We have no evidence for localized distortions that strong. They say, possible, but unproven. The chalk moves once more. Thought experiment 3. What if the star didn't disappear? What if time around it shifted? This one makes you breathe a little deeper. You imagine a star falling into the gravitational well of a massive object, like a black hole or neutron star, not close enough to be consumed, but close enough for time itself to dilate. From your perspective, the star's light slows and stops, not because the star is gone, but because time around it is almost frozen. A star paused in cosmic time. You picture the photons trying to escape the slowing region, each one stretched, delayed, reddened into invisibility. By the time the light reaches us, it no longer exists in any detectable wavelength. The scientist smiles at this one. Unlikely, they say softly, but beautiful, and maybe not impossible. Then they draw a circle. Thought experiment 4. What if stars can tunnel between states the way particles do? This one startles you. We know particles can quantum tunnel, vanish from one place, and reappear in another, bypassing barriers through probability rather than force. If matter on a small scale can do this, could a dying star, under extreme conditions, behave in an analogous way? Could its core collapse in such a way that matter transitions into a different state entirely, leaving no explosion, no debris, no observable remnant? You imagine the star folding into itself, slipping into a new form, a transition so delicate and instantaneous that the universe barely registers it. But again, the scientist hesitates. Quantum laws don't scale that way, they say. Probably. And you both let the thought fade like starlight. Now the chalk draws something stranger. Thought experiment 5. What if the star experienced a partial collapse, a transition that hides its light but doesn't destroy it? You imagine a star whose outer layers remain intact, but whose inner core collapses into a compact object. The star continues shining, but the gravitational effects warp its light so severely that it arcs away from Earth in every direction. To us, the star is gone. To the universe, it still burns. This one lingers. It feels almost plausible. Gravity is mysterious. Light is delicate. The balance between them is subtle. And then comes the boldest sketch of all. Thought experiment 6. What if stars have life cycles we have not yet discovered? You breathe slowly as the scientist places their chalk down. We assume stars end in predictable ways. White dwarfs, neutron stars, black holes. But what if some stars undergo transformations we have not yet witnessed? New forms of matter, exotic states of collapse, intermediate stages between known fates. Perhaps a star could fold into a quark star or a boson star, theoretical objects predicted by certain models of particle physics. Such transformations could be sudden, silent, and nearly undetectable. The universe is old, older than our theories, older than our assumptions. You imagine the star dimming, not because it dies, but because it evolves into something that no longer emits familiar light. A chrysalis phase of stellar metamorphosis. No explosion, no debris, only transformation. As you let this idea drift across your mind, you sense something comforting in the uncertainty. Thought experiments are not answers. They're bridges, ways to reach toward explanations that remain out of reach. The scientist erases the board softly. The truth, they whisper, is that we do not yet know. But every disappearing star is a gentle invitation from the universe to imagine more boldly. You breathe in the quiet, letting the possibilities settle like falling dust. The mystery is not frightening. It is spacious, inviting, patient. And now, carried by these imaginative threads, you drift into the next chapter, a journey into the future, where new technologies may finally reveal what the disappearing stars have been hiding all along. You drift deeper into the soft darkness of the cosmos, and now your thoughts turn toward the tools we haven't built yet. Instruments still on drawing boards, sensors still in prototype rooms, telescopes still imagined by scientists who dream of seeing what today's technology cannot. As your breathing slows, you begin to sense something hopeful in this chapter. The mystery of disappearing stars is not a closed door. It is an invitation, quietly urging humanity to sharpen its vision. Tonight, you step into the world of future observation technologies, the next generation of cosmic eyes that may finally reveal what hides behind vanishings in the night sky. Imagine, for a moment, standing inside a massive clean room. The air is sterile and dry. White panels glow overhead. Before you rises the skeleton of a machine so advanced it feels almost alive. A next-generation space telescope with a mirror the size of a small building. Engineers move around it like caretakers tending a sleeping giant. This could be one possible future. The Louvre telescope, a proposed observatory far larger and sharper than Hubble or even James Webb. Its mirror, tens of meters wide, could watch the sky with unprecedented precision. It would not just detect disappearing stars. It would track the smallest changes in their light, temperature, and motion. If a star collapses, Louvre would see the shockwave inside. If dust hides it, Louvre would map the dust grain by grain. But Louvre is only one possibility. Now imagine another. The Einstein probe, designed specifically to detect fleeting X-ray events, the whispers of stellar collapses, failed supernovae, and black hole births. It could catch the tiny pulse of high-energy radiation released before a star vanishes, capturing the moment of transition that all current telescopes miss. And then there are the gravitational observatories, perhaps the most exciting of all. You picture LISA, the Laser Interferometer Space Antenna, floating quietly in a triangular formation millions of kilometers across. It's not looking at light. It's listening to space-time itself, waiting for vibrations caused by black hole formations or stellar collapses. If a star vanishes by falling silently into a black hole, LISA could hear its final gravitational sigh. You breathe softly as you imagine these instruments working together. Light telescopes, infrared arrays, X-ray monitors, gravitational listeners, forming a network that never sleeps. Every disappearance will be caught in real time, every flicker documented, every quiet and observed. But the future stretches even further. Some scientists imagine quantum telescopes, devices that could detect single photons arriving from stars so faint they are invisible to all current instruments. Others propose distributed swarms of microsatellites, tiny sensors forming a vast mesh across the solar system, each one watching a small piece of sky. Together, they would create a complete, unblinking map of every star's brightness. In such a future, vanishings wouldn't slip by unnoticed. They would be recorded from multiple angles, multiple wavelengths, multiple distances. A disappearing star would become not a mystery, but a moment. The exact second its light stopped, the path it took, the energy signature it released, the behavior of its surroundings. You imagine drifting beside one of these future satellites, small enough to hold in your hands, delicate as a snowflake of metal and glass. It hums quietly, collecting data. One day, it detects a sudden drop in starlight. Not a flicker, not a dimming, but complete absence. It signals the network. Dozens of sibling satellites pivot toward the coordinate. Within seconds, telescopes across the solar system respond. The universe tightens its focus. And this time, nothing is missed. Scientists on Earth and Mars watch as the star's light signature dissolves. A second instrument detects a flash of neutrinos. A third records gravitational waves. A fourth maps dust distribution. The mystery doesn't vanish. It unfolds. You breathe gently, letting this future settle into your imagination. It feels like standing at the edge of a great discovery, one humanity is slowly but surely approaching. Yet, as the science grows sharper, the debates will continue. Some researchers argue that technology alone won't reveal the truth. Others believe that with enough data, even the strangest vanishings will find natural explanations. A few hold on a hope that these observations may show us something truly new, a doorway into physics we haven't yet discovered. But all agree on one thing: the cosmos is changing, and we are learning to see its changes with new clarity. You let your mind drift over these visions, giant mirrors unfolding like petals in space, gravitational detectors listening to the tremble of collapsing stars, swarms of satellites drawing delicate diagrams of light across the sky. And as this quiet, futuristic panorama drifts across your mind, you sense the next chapter approaching. The realization that the universe itself may flicker, shimmer, and behave unpredictably. Not because of anything artificial, but because chaos and wonder are woven into its very structure. You drift deeper into the gentle silence of the cosmos, and now the darkness around you begins to shimmer. Not brightly, not sharply, but with a faint, irregular pulse, as if existence itself flickers at the edges. Your breathing slows, matching that soft cosmic rhythm, and you begin to sense something essential. The universe is not a stable, unmoving stage. It is restless, dynamic, forever shifting in ways we barely understand. Tonight, you step into the idea of the flickering universe, a cosmos where change is not an anomaly, but the natural state of being. And in such a universe, disappearing stars may not be mysterious exceptions. They may simply be reminders that nothing in the sky is as constant as it appears. Imagine the night sky stretched above you like a vast tapestry. For thousands of years, humans believed it was fixed, a perfect backdrop where stars held steady positions, shining with unwavering consistency. But as you breathe gently now, you sense the truth. The sky is not a still photograph. It is a time-lapse, a ceaseless flow. Stars pulse, stars drift, stars flare unexpectedly, and some stars blink out. You visualize a star shimmering in the distance. To the naked eye, it seems stable, but deep inside it, turbulent convection currents rise and fall like boiling water. Magnetic fields twist, knot, and unravel. Nuclear reactions accelerate or falter. Even its surface shifts with cycles that span decades or centuries. A flicker here, a brightening there, a sudden drop in temperature. Stars are alive in their own way. Restless furnaces trying to balance unimaginable forces. And sometimes, their restlessness becomes global. You picture a star entering a chaotic evolutionary phase, where light output becomes unpredictable, It may dim abruptly for reasons we still don't understand, only to brighten again years later. Or it may fade so drastically that it becomes invisible from Earth for a generation. In such cases, the star hasn't died or collapsed. It has simply moved into a new rhythm of existence. Astronomers call these behaviors irregular variability, and they've discovered that more stars than expected behave this way, flickering dramatically for centuries and then stabilizing. Because our window of observation is short, a single dimming event might appear permanent to us, but temporary to the star. You breathe in slowly as your mind drifts toward even stranger possibilities. What if the universe flickers not just in stars, but in space-time itself? Cosmologists speculate that space-time may have small, momentary fluctuations, quantum ripples that bend the path of light ever so slightly. These ripples could, in theory, distort the brightness of distant objects in ways we barely detect today. Now, imagine thousands of such fluctuations overlapping across the galaxy. Light waves from distant stars bend unpredictably. For a short while, their paths reach us perfectly. Then something shifts, a ripple, a distortion, and the light is carried away from our viewpoint. When we look again, the star seems gone, not destroyed, not hidden, just out of alignment with our eyes. A cosmic blink. You hold that idea gently in your thoughts, as if feeling the breath of the universe itself, steady, rhythmic, but never absolutely constant. There is another layer to this flicker, the movement of the galaxy. Stars orbit the galactic center at tremendous speeds, changing their positions over millions of years. Cloud structures shift, gravitational lenses drift. The entire Milky Way behaves like a vast, swirling ocean. And in an ocean, waves interfere, shadows form, light refracts, visibility changes from moment to moment. Why should the cosmos be any different? You imagine the universe as a giant, shimmering field, a mosaic of gravitational distortions, dust filaments, plasma ribbons, dark matter tides, and magnetic waves. A star's visibility becomes a delicate alignment of countless variables. If even one shifts, the star's brightness at Earth can change drastically. Some astronomers believe disappearances might be part of these large-scale cosmic rhythms, statistical outliers in a universe far more unstable and intricate than we assume. Not a sign of catastrophe, but a sign of complexity. You breathe softly, letting this idea settle. The universe is not steady. The universe moves. The universe blinks. And sometimes, those blinks last a long time. The thought carries a quiet comfort. Not every disappearance is dramatic. Not every vanishing is final. Some are simply the result of living in a universe where change is inevitable, constant, and woven into everything that exists. You look up again, in your mind, in your imagination, and the stars twinkle not because of Earth's atmosphere, but because the universe itself is full of motion, transformation, and subtle shifts that the human eye is just now beginning to understand. And with that realization, your thoughts drift gently into the next chapter, where the mystery of vanished stars becomes personal, touching even our understanding of the fate of our own sun. You drift deeper into the quiet, velvety darkness of space, and now the mystery of disappearing stars begins to feel closer. No longer a distant curiosity, but something that whispers directly to your understanding of our own solar system. Your breathing softens as you contemplate a gentle but profound realization. Every vanished star is, in a way, a preview of our sun's future. Not literally in its disappearing act, but in the reminder that stellar lives are not eternal, and their endings are quieter, stranger, and more varied than we once believed. Tonight, you step into the emotional heart of this journey. What vanishing stars can teach us about the fate of our own sun, and what that means for us. Imagine the sun hanging in the sky as it does now, steady, bright, warm. For all of human history, it has been the most dependable thing we know. Day follows day, season follows season, life grows under its light. Yet stars that look just as stable as our sun have vanished elsewhere in the galaxy. Some collapsing silently, some slipping behind dust, some flickering unpredictably in their final stages. So you breathe slowly, letting the thoughts settle. Our sun, too, has a destiny written in the language of stars. But unlike massive giants that end in dramatic explosions or quiet collapses, the sun's path is gentler, more patient. It will swell into a red giant long after humanity has evolved beyond its current form, or long after we have found new worlds to call home. And when it dies, it will not vanish suddenly or mysteriously. Instead, it will exhale its outer layers into space, forming a glowing nebula, beautiful, soft, like a cosmic sigh, before shrinking into a white dwarf that slowly cools over trillions of years. Yet the disappearing stars remind us of something deeper. They show how little of the sun's true story we can see from Earth. If other stars can hide behind dust, fall into invisible states, or flicker through physical processes we don't yet understand, perhaps our own sun carries secrets we haven't discovered. You imagine astronomers of the far future watching the sun from distant worlds. To them, the sun may appear different, dimmed by interstellar dust, or distorted by gravitational turbulence, or flickering slightly due to changes in its magnetic heartbeat. The sun may not vanish, but its visibility and behavior will evolve in ways subtle and profound. And then comes a softer, more personal realization. You breathe gently as you imagine the sun not as a ball of gas, but as a companion, one we take for granted, one that quietly shapes every moment of life on Earth. Disappearing stars remind us that stars are not eternal guardians. They are living, changing, aging entities. One day, the sun will grow old too, and far beyond Earth's timeline, its light will dim and fade, just as other stars have before. This isn't frightening. It is comforting in its cosmic honesty. The universe transforms everything. Eventually, stars vanish, nebulae dissolve, galaxies collide, even black holes evaporate over unimaginable spans of time. And yet, the universe continues. New stars ignite from the ashes of the old. New worlds form. New possibilities emerge. You breathe in this rhythm. Beginnings, endings, transformations. And then another thought surfaces, gentle, unexpected. What if disappearing stars are also messages? Not messages written intentionally, but messages of perspective. Warnings that even celestial giants can vanish quietly. Reminders that our view of the cosmos is incomplete, filtered through dust, gravity, distance, and time. Disappearing stars whisper to us, "You do not see everything. You do not know everything. The universe still holds mysteries." This humility is powerful. It shapes the way we imagine our place in the cosmos. It reminds us that our sun, though familiar and steady, is still a star woven into a fabric far more dynamic than we can perceive. You visualize our descendants, millions of years from now, watching the sun with instruments far beyond our imagination. Perhaps they will see subtle shifts we cannot detect. Perhaps they will witness the sun flicker in ways we cannot yet explain. Perhaps they will understand its future with clarity that escapes us now. Or perhaps they, too, We'll look into the sky one day and see a star that once shone brightly and is no longer there. But this thought brings not fear, but serenity. Because the story of stars is not about disappearance. It is about continuity. Even when a star vanishes, its matter remains in the universe. Its atoms drifting into nebulae, birthing new stars, becoming planets, becoming life. Every vanished star becomes part of something else. And so will our sun. You breathe slowly, deeply, gently. The universe is not losing stars. It is recycling them, rewriting them, transforming them into the next chapter. And now, with this softened understanding of cosmic impermanence, you drift toward the final part of this journey. A closing reflection that gathers all these mysteries and guides you toward rest, serenity, and the quiet beauty of not having every answer. You drift now into the softest part of the journey, the place where all the mysteries you've explored begin to settle like stardust on calm water. The night around you is wide, gentle, and endlessly patient. Every explanation you've met so far, collapsing stars, drifting dust, hidden objects, gravitational illusions, even ancient civilizations, now blends into a single, quiet truth. The universe is filled with more possibilities than we can hold in one lifetime. And yet, here you are, floating through them with ease. Tonight, you gather the entire cosmic mystery of disappearing stars and hold it gently in your hands, not as something that needs solving, but as something meant to be felt. Imagine yourself standing at the edge of a meadow under a dark sky. The stars shimmer above you with their strange, ancient rhythms. Some flicker, some pulse, some burn steadily, and some are simply missing. But instead of fear or confusion, you feel a soft curiosity, a sense that every absence tells a story of its own. You breathe slowly as you remember the vanished giants, the stars that collapsed silently, sinking inward until their light could no longer escape. You recall the dusty veils drifting across the galaxy, hiding stars for centuries or more. You picture the dark wanderers, rogue planets, black dwarfs, invisible remnants, casting quiet shadows across stellar light. And then your mind wanders to the gravitational mirages, bending light like water through glass. To the ancient astronomers who watch stars wink out without explanation. To the satellites today that record faint disappearances in their unblinking archives. To the debates, the hypotheses, the unanswered questions. Each one a brushstroke in a mural the universe is still painting. As your thoughts settle further, you begin to see how these mysteries reflect something deeper. Stars do not vanish from the universe. They vanish from our perspective. Such a gentle reminder of how limited our view truly is. How vast the cosmos remains. How much beauty exists beyond the edges of what we can see. You imagine a star that disappeared from our sky long ago. Perhaps it collapsed into a black hole. Perhaps it hides behind a drifting cloud. Perhaps its light bends away from us now. Perhaps it transformed into something exotic. A quark star, a strange star, a new state of matter. But somewhere, in some wavelength or dimension or cosmic time, the star still exists. Nothing truly disappears. It only changes form. It only changes direction. It only changes meaning. This truth hums softly inside you. You breathe deeper now, and the universe feels gentler, less like a cold void, and more like a living tapestry where even the quietest events have purpose. The stars that vanish remind you that even the brightest parts of life can shift, dim, or drift behind veils we don't yet understand. And yet, like the cosmos itself, we endure. We adapt. We continue. You picture yourself floating slowly between the stars. Each one is a story. Each one is a memory. Each one a reminder that existence is fragile and magnificent at the same time. And even when a star disappears, its light continues to travel across the galaxy for centuries. A final message drifting through the void long after its source has changed. As you drift deeper into this thought, the edges of the universe blur softly. The mysteries no longer demand answers. They simply invite awe. Stars vanish. Stars reappear. Stars transform. And the cosmos whispers its gentle truth through every change. Nothing is ever truly gone. You let your awareness soften even further. Your breath slows. The vastness around you grows warmer, quieter, more tender. The sky above feels deep and soft, like a blanket woven from memory and possibility. And as you sink into this final moment of reflection, you sense the approach of sleep, a gentle descent into your own inner universe, where thoughts flicker like distant stars, where memories drift in and out of view, where dreams rise quietly to fill the sky. The journey has carried you through centuries of observation, through theories and illusions, through dust, gravity, collapse, and imagination. And now, as the night folds around you, the last lingering mystery is not what happened to those stars, but the quiet, peaceful feeling they leave behind. It is time to rest now. Time to let the stars fade softly from view. Time to follow the universe into its calm, endless drift. Wherever you are, let the world slow down. Let this quiet understanding settle into your chest like a warm, steady glow. Let the hum of the cosmos guide you into a serene and restful night. Nothing is lost. Everything transforms. And you, drifting gently now, are part of that beautiful, eternal cycle. The night around you becomes softer now, as if the universe itself is exhaling. The mysteries you've traveled through, the disappearing stars, the silent collapses, the drifting dust, the gravitational bends, the cosmic shadows, all grow quieter, fading into a gentle background hum. You don't need to hold them anymore. You don't need to understand everything right now. The universe has been carrying these questions for billions of years. It can carry them a little longer while you rest. Your breath slows, warm and steady, grounding you in this moment. The stars above may flicker, shift, vanish, and reappear, but your body knows exactly how to relax, how to follow the rhythm of calm. Each inhale brings a soft wave of ease. Each exhale releases the tension of the day. You feel yourself sinking deeper into comfort, as if gravity itself has grown kinder. Imagine the sky turning velvety, the stars dimming into tiny embers. Not gone, just resting, just drifting behind some cosmic curtain the way thoughts drift behind dreams. The universe quiets around you. Even time feels slower, more fluid. There is no urgency here. No need to solve anything. Only the soft presence of being. You are floating now, gently, as though held by the same fabric that holds the galaxies together. Every distant star, every vanished light, every silent mystery belongs to a universe that has room for all things. Clarity and confusion, brightness and shadow, endings and beginnings. Let yourself drift with it. Let yourself soften. Let yourself rest. You've journeyed far tonight, and now the cosmos is inviting you to let go.